Now I am unmuted. I don't know, am I audible anywhere? Is someone listening?
No, you have viewers.
Wait, you say something. Say something.
I am saying something.
No, unfortunately not. I don't think it's coming through.
That is weird.
Oh, other can hear us.
Okay, can you hear us?
Yeah,
Okay,
and,
okay, okay.
yeah, and our viewers tell us that.
So hello guys, you can hear our church calling at 6 p.m. It means we should start our workshop right now. And today with me will be Hiba. You didn't met her. So our August workshop met her. So let me introduce myself. I forgot to do that last time. My name is Alena. I'm a DevRel at dlltHub. Probably you met me in Slack community. I'm trying to help you there, answering questions and creating workshops and something else. So today we're gonna talk about more advanced things like custom incremental loading, like retries, logging, tracing, performance, how to create custom sources, custom destinations, and try to deploy things with GitHub Actions, Dagster, and Lambda Function. So Hiba will start.
All right. Hello. So I am Hiba, as Alona said, and if you haven't seen me before, I also work at DLT as a working student, and I also may or may not have answered some of your questions on Slack. Yeah, I work with data. I'm a data scientist. So data, machine learning, analytics, that is my bread and butter. So, right. Start.
Share the full screen.
Okay.
Entire screen, not the window.
Okay. You see?
Not yet.
Yeah.
Is it up? Okay. So we will start with a bit of a recap from our previous workshop. So we've covered a bunch of topics before, and we will be doing that again here as well. This time we will have a bit of a more hands-on approach. So let's just get started. First, we will do a little bit of a recap, and then with every section, we will also do a recap, and then we will go into some tasks. So yeah. In the previous workshops, we started with DLT sources, resources. We learned how to configure secrets, incremental loading. We saw verified sources and destinations, discussed how to use those different sources, including file system. And yeah, we worked with schema, metadata, different things regarding your DLT pipeline as it is. So yeah. In the previous workshop, by the end of it, we came up with this working pipeline. So we were working with the GitHub API for the entirety of the workshops, and we looked at the issue source, we looked at the pull requests, and then we combined them and then created a pipeline for it. So we are still installing DLT. Done. Okay, so yeah, for this, you should be able to add your own access token for your GitHub API into Colab right here. So you will have your secrets manager type thing, and you can add your own access token here. And if you don't want to do that, then you'll have to remove the authorization from the headers in your request module and all of the requests that you sent. Yeah, but if you want to keep this, you will have to enable an access token. Right, so this entire thing has been run. We saw that we created an issues table, a pull request table, and then we have child tables from both of those sources as well. Now I forgot to say, you should have access to this collab. You should either copy it with yourself, run it as we go so that we can all be coding together, and yeah, either copy it or work with it on playground mode so that we can all be on the same page. Right. So this is as far as what we've the mini project that we kind of did in the last workshops. We used source resource, we enabled secret access code, we put in the right disposition here as replace. So we did a bunch of things here and created a GitHub pipeline with issues and pull requests. So now here we will be going forward to a little bit more advanced concepts. And here are some links to all of the previous different collabs that we have done in the previous workshops. And yeah, we'll just start with the first one here, which is custom incremental loading. So as a refresher, we have different methods and different ways of loading data incrementally. And if we look at, please let me know that the screen has been shared.
Our screen.
Yeah, okay. Cool. Right, so yeah, we have the different methods of loading data incrementally. If you remember, we have append, replace, merge. We have different strategies to be able to merge, depending on whether or not you have stateless or stateful data. If these words kind of seem new to you, just go into these collabs and then, it would be a good refresher for you. Right. So we will not be going over this entire thing. This is just a refresher. So just to remind you, there is one very important concept when it comes to custom incremental loading, and that is of a cursor field. For you may have that as updated at or created at, and it's basically to be able to keep track of from when you are loading data or till when you are loading data. So you can use this as, for example, like this. You have here your your cursor field is created at, and you use that with a certain date and you load it. For example, you are running this pipeline and loading all of the issues since the 1st of January, right? So that is your cursor value. You can use it with an initial value. Then you have a customizable way to be able to keep track of this cursor value, which is through the last value func. This is an argument that you use to, again, right, be able to keep track of your cursor value, whether you want to keep the minimum value of the cursor field that you are looking at or the maximum one. You can either define it as a customizable thing, or you can just put in min or max right here as an argument. So we have covered the cursor value, your own customizable way to be able to keep track of it, an initial value, and then now you also have an end value. So for example, before we just loaded data from the 1st of January this year, and now let's say that you just want it for like the first 6 months or whatever, you can also put your end value as well to be able to kind of backfill your data. Right. What else do we do here? Right, you can also optimize your backfill. We have an initial value and end value, and you can optimize it using the row order, which will basically define the order in which these cursor fields are being tracked and loaded. And then the place where your cursor field is saved, which is basically your pipeline state. You can access it inside of your pipeline state, inside of your sources or particular source name. And it will be saved with the last value key. So you can use this whenever you're loading data, whenever you are just trying to keep track of your cursor field. All right, I think that is a good enough refresher of everything that we have covered in custom incremental loading so far. And now we can move on to our task. And I hope by this point in time you have created a copy or have opened this notebook in playground mode. And you can start with these exercises basically. So the first one is to use the last value func, and by default it is set as max, and you have to change it to min. And here you have a little bit of basically starter code. You've already launched your pipeline here with your different sources, with issues and pull requests, and now you need to basically run it again with your last value func as min. And since we're starting off, this is an easy one. I will give you 1 minute to finish it off. And yeah, your time starts now. Let us know if you're facing any issues. You can tell us on Slack.
It is. I'm sharing collabs,
Sorry.
presenting collabs. I'm sharing them right now.
Okay.
Sure.
In all of these different tasks, if you get stuck, you can refer to the different collabs that we have covered in the previous workshops. You can look at the docs. You can ask dlltHub. Please ask dlltHub. Right, so 1 minute is almost over now. If you've done it, amazing. If you haven't, that's okay. We can do it together. All we had to do was change the last value func from max to min. And we can run this. And we've run it, we've run the pipeline. The issues resource has now been loaded with the last value func as min. And now we can run the pipeline. Cool. So we have a load package here. Right, the issues resource has been loaded, normalized. Yeah, and we're basically done. If we want to look at the last value func, it is there we go. We have an initial value and a last value, and as we said, it's saved in the last value that we see. We had kept it as minimum, so it took basically the minimum value of the data that we loaded, and it saved it. Right. Now we move on to the second task, which is the end value. So as a recap, we did initial value, and now we have an end value as well. So this is, we're starting another pipeline, GitHub issues backfill, and yeah, we just have to run pipeline.run with the correct initial and end values, and you have to load data only for June of this year. Yeah, we added dates so that you don't get confused with the format, but you just have to change the date here. And once again, let's start the timer. You can change the date. Awkward silence.
Waiting for dead jokes.
Yeah.
Don't do this.
Oh yeah, I saw the meme. Please share memes. Okay, so that is 1 minute over. Now we wanted to put data for just this year, June. So I'll put in this year, right? So that's, yeah, so the first day of June till the first day of July. And that should load all the values for June. Alrighty. We loaded the issues labels, issue assignees, the parent and child tables, and we saw that the minimum date was the 1st of June, and the last issue that we received in June was on the 27th of June. Cool. So that were the two exercises from custom incremental loading. Now we can move on to schema configuration and data contracts. We won't be touching much upon schema configuration right now. We'll be focusing more on data contracts. And just as a reminder, data contracts are basically the rules and laws that you put on your data so that not everything can be put into your database and you can maintain the integrity there. So let's look into what we have covered in this so far. I'll skip over, yeah. Right, so we have different levels when it comes to defining these rules and these laws on your data. So you have your table level where you have the two rules as evolve or freeze. Evolve basically allows the creation of new tables within a schema, and freeze means you don't want anyone to be adding any new tables. So whenever your pipeline is running, it tries to add any new tables, DLT will stop it from happening. Right. And that's right. Then we have the other level. After the table level, you have the column level. Again, evolve and freeze. Evolve allows the addition of new columns, freeze prevents it. Then you also have two more rules, which are discard row and discard value. Now, this gets into a little bit more of the detail of your tables, and discard row basically skips the rows that have new columns but loads those that have the existing schema. So you have discard row and discard value, and then discard value does not skip the entire rows. That means even if something goes against your rules or your contracts, the entire row will not be deleted, just the value will. So, right, this could basically be anything from a wrong data type or anything, right? Then you have, by the way, this is the syntax. Again, as a reminder, this is the syntax of how you define your schema contracts, for example, for columns or tables, or the last one, data type. So for data type, again, you have evolve and freeze. Evolve means if you're adding an age for someone and the first time you loaded your data, you added an integer, the age, then if someone wants to add another row or something with text as age, that will be allowed in evolve. That will not be allowed in freeze. The entire pipeline will be stopped. Discard row will basically, take that particular row with the wrong age data type and discard it. Discard value will then just discard that particular age and load the rest of your row. Right, so that was a refresher. Yeah, I think that's enough for the refresher. Just another look at how you define these schema contracts right in the resource, just like that. So coming back to your tasks. Okay, let's load this first. We are here, we're loading a particular issue, number 1708, into a DuckDB table called issues. So yeah, this is our URL, issues 1708, loaded into a table called issues. Let's load it. Right. So we have two tables that were basically loaded, issues and issues assignees. So this is the parent table, this is the child table, and yeah, that is what we have in our data set. Now let's come over to our particular task. Now say that now that you want to load the rest of the issues, right now you just loaded one of them, you want to load the rest of them, but you want to do it with a particular schema contract, which is basically you want to set tables to freeze, you want to set columns to discard value, and you want to set data type to discard row, right? And yeah, you basically want to define your resource this time with a particular schema contract, and you just have to set that here. And once again, I will put 1 minute on the clock, and you can start off by adding your data contracts here. Please feel free to look at the old collabs to look at the syntax. Fifteen seconds. And that is 1 minute over. So let's do it together this time. I'm just going to copy paste it from here. We want to set our schema contracts. We want the tables to be frozen. We want the columns to be set at discard value. And we want the data type to be discard row. Once again, the most strict of these data types here is freeze, so you cannot add any more tables into what you already have from issues and issues assignees. And when we try to run this, we get a data validation error. And that is basically because in the schema, issues underscore labels was trying to be added into our database, and that violates the schema contract that it should be frozen. So let's try and fix it. Let's try and be a little more lax on that subject and add the set the tables schema contract to evolve. Let me just copy paste it back. Evolve. And we still can't get through. Let's see why. Right, so here we see that the pipeline step has failed because it's still on the last error. So when we look at the load package, we see that we do have a failed job here. So what we will do is basically clear out our pipeline state, and we can do that with the command DLT pipeline, the name of the pipeline, and the word sync. This yes basically means it will ask you here if you want to proceed, and here you would write yes. And in one sentence, you could just go ahead and do that. So now when we try and run this again, cool. So the total number of issues returned from the API is 100. And let's try and make sure that that's the entire. Yep, so there were 100 issues loaded into our database as well. So that's pretty cool that, GitHub allows you to be able to do that. And none of the rows were actually discarded because the integrity was maintained. So that is pretty good on part of the GitHub API. Right. Now we move on to tracing, logging, and retries. So as a refresher, we have different ways to be able to, for example, the error that just showed up for us for data validation for our schema contract being that it went against it. You can trace and then find ways to be able to log those errors as well, and just be able to know what's going on in your pipeline. So let's look at what we have covered before this. Right. As a refresher, what is inspecting? So you have your load packages, as we just looked at in the previous example that we did. A load package has a certain load ID. You can see different things like, when it was started, when the job had started, how long it took, what completed jobs there are in it. There are ways to access this through Python, and there are also ways to access this through the CLI commands. So, yeah. Right, so we already know what it looks like whenever a job fails. So let's not get into it again. Then we have our traces. So as you saw, we also looked at traces over here. It's somewhere in the beginning. Let's leave it. So you can look at the last trace, which is basically the last thing that you loaded, or your last load info, and it has information about all three steps: extract, normalize, and load. So you can look at your last traces: extract info, normalize info, and then load info as well. And you can also then take that information, put it back into your database just to be able to see what errors you have and basically keep track of them. Then you have Sentry, which we will not be doing in the exercises, but again, DLT, you can enable Sentry with it. What is Sentry? It is a platform. It's an open source error tracking tool, and it basically takes you to your own dashboard where you can see whatever errors come up in your Python code. For DLT, you can enable it using your environment variables or configuration config.toml files, and it will also log, for example, your job issues inside your Sentry dashboard as well. Then you have logs. When it comes to tracking errors, we would be completely lost without logs, of course. So you have different levels of logging. You have debug, info, error, critical. That's what you have in Python. Logging in DLT, you can set your log level inside your config.toml file, and then also as an environment variable. So you have info, critical, debug, as your different levels of logging, depending on how much information you want to see about your pipeline. Info will basically show you everything, all of the steps, debug a little less, and then critical will disable logging for good. So this is how you attach your logger. And then, yeah, you just run your pipeline after attaching it to a file called dlt.log, where all of your logs will be handled. You will see your log messages show up whenever you're running your pipeline like this. And that's a lot of it. Then there are other methods like using log guru, and yeah, you can also see logs for progress, where basically whenever you're running your pipeline, you can set the progress argument to log, and you will see the progress logs for each and every single step: extract, normalize, and load. Right, so that was what we had covered before. Where are we gone? There we are. Right. So now what are we doing? We are doing another resource, the issues resource, and we are loading data into our pipeline, once again, with a particular schema contract, with the tables as evolve, columns as discard value, and data type as discard row, same thing as what we were following. Successfully, your data has been loaded. And now we want to do another load and basically set your log level to see progress. Now we just covered that, and you have to do it again. So I'll give you another minute for that. And yeah, you can start.
You can drink.
I can drink. I'm drinking.
Cheers. This pause is not only for tasks, but also to take
a breather, yeah. Another 30 seconds. And your minute is over. Now let's do it together. We had to set our, oops. Oh wait, we didn't run this, yes. Right, we had to set progress to log, and now it logged whatever step the pipeline was going through. It was telling you its story through extract, normalize, and load. And successfully it was loaded with no failed jobs. Congratulations, if that is what you got. If not, I am sorry. Yeah, then we move on to changing the log level. So as we discussed, there are two ways to set this. One is using your config.toml file, and then the other one is through environment variables. With our experience, we can tell you that it is very hard to use toml files here inside, these hidden files in Colab. So let's do it on basically our environment variables, which you can set directly in Python like this. So the timer will start again, and you can set your log level to debug. You can look at the syntax in the previous file that we just looked at. I hope I remember the syntax.
You can read it in my chest.
What? I'm sharing my entire screen. I can't read from this. You will have to tell me if something funny happens.
I'm sharing jokes.
Okay. Okay. That is the minute over. Alena is having the time of her life. Okay, let's hope I remember this correctly. It's ntime_log level. And we set that as...
So there's a hint on top, yeah, for tone. Yeah, that's
Cool.
Right.
Yay. We have the debug ones showing up. So that's cool. Again, it got loaded and no failed jobs. So we are through with with the logging section. Now we can look at the retries, and yeah, whenever you're sending requests in Python or just using different APIs to load data, retries is something that is necessary sometimes to be able to try a link again and again to see if whatever error you're facing goes away. Okay, so within DLT you have your requests wrapper, and you can import it this way. Like you can use your normal requests as import requests, and you can use the request wrapper from DLT as dlt.sources.helpers import requests. And it works the exact same way as the requests library with some added functionality which you will use for your retries. So there are some rules. We won't go through all of them, but yeah, the main ones are that your failing requests are retried up to 5 times. Your status codes that are, I think it's up to 500. Yeah, for all status codes in 500 and 429, it works. Right. So those are the different levels. You can look at the docs or this collab to look at the extra ones. So let's see what it might look like. So for example, you are, our favorite endpoint of today and all of the different workshops is the issues endpoint. Let's say that you misspell GitHub here and you have sent your request with your request wrapper wrapped around this URL. You can see that it retried this 5 times before failing, and yeah, thus this functioning the way that we just said that it would. You can customize this, for example, changing your maximum attempts from 5 to 10, and there are different configurations for different things that you might want to change for retries, like the timeout, etc. So you can do that as well. Right. So again, you can fix that inside your config.toml files, and you can also do that in your environment variables as well. So yeah, let's say that this was amended here from 5 to 7, and again the GitHub API is called, and you can see that it is tried for 7 times before failing. Right. And then you have your custom client that you can declare as well for if you want to look at some particular status codes and exceptions. This is basically if you want more control over how your requests are handled beyond the config.toml files, and it allows you to customize the behavior of the client, including which HTTP status codes and exceptions will trigger retries. So, for example, we have the 403 error, which is a bad request error, I think, forbidden response, right? And we have a client declared here, which will work for these 403 status codes, and no other exceptions. So GitHub API, which allows 60 requests per minute, we are going to try and bombard it a little bit more. So you see that it goes up to 60, and on the 61st attempt, it will retry it 7 times, just like we told it to, and then it will give up. So now when we do our incorrect API endpoint, you see that this our custom client will not retry it because these scenarios are not specified in the custom configuration, which is basically this is a wrong endpoint and 404 not found. And when we declared the client, we did not say that it should work for a 404, so it did not. Right, then there are some other ways that you can customize your request wrapper and handle these retries, which you can look at inside of this collab. So coming back, say that we are going to try and make the same error again. We have the GitHub API endpoint, which will cause a failure. And we see that we are using the request wrapper here. So it is trying 4 times. And it retries it 5 times before giving up, just as we would expect it to, because that is the default behavior. Now we want to declare our own custom client, and we wanted to enable retry for only 403 and 500 status codes and nothing else. So this is the code that has been laid out for you, and you just have to fill it in. And I will put 1 minute back on the clock. And you can refer to the other collab for this. All right, so that's 1 minute up. And now we can do it together. So we want to enable retries only for 403 and 500 status codes. So, right. And no exceptions, we don't care about them. Right, it worked. Now let's run it again for the incorrect API endpoint, which we just saw. It will go into a 404 error. And it does not retry as we just told it to. Since we did not specify it for 404, we just specified it for 403 and 500. You see that it did not retry anything and just gave you an error. All right, so now we can go into the bonus, and this time you don't have to do anything. You can take a bit of a breather before we get back into the other tasks, and we can start with the DBT Runner. Well, if you remember, we have covered this before. I have so much open. Right. So let's say that once again, we really love this API endpoint. We want to see all of the issues in DLT again. To see the DBT runner in action, we need some data already loaded, which again, this code has been set up. It's the same thing, nothing else. See, initial value is the 1st of January this year. And yeah, we will create a pipeline with this particular data set. So let's just run this file. Okay, so it ran. We have no failed jobs, and we can see this DuckDB data set here available for us. Now, before we model anything with DBT, which I just realized I didn't introduce DBT for those of you who don't know. So you have DLT to be able to load, extract, and load your data. So where you have the ELT, DLT does the extract and load. And if you want to transform your data, that is where DBT comes in. And what we will be doing here is taking these issues, and basically we saw that we have a parent issues table, and then we have some child issues tables, and we will basically put it into one master table, which is a very common thing to do when it comes to data projects, creating one source of truth to see where everything is, and that is what we will be doing. So let's start a DBT project. Before we use our DBT runner, we need to start a DBT project, and I'll do that with dbt init, and I need to give it a name, runner workshop. Okay. Happy modeling. I would like to use DuckDB. This should, there it is, the runner workshop. So here we have our models. So this is basically an example. You can declare your schema inside a YAML file, and then you can declare what goes inside of it in SQL. So I will be deleting this, and we'll be creating our own. Oops. Schema.yaml. And I'm not going to write everything from scratch. We will look for dlltHub education, and we will take the model from there. And this repository also has some extra information about the things that you need to install to make it work, which is not a lot. It's just DLT, DBT, and DuckDB, but it has the instructions to be able to do that. Right, so what do we have here? We have a model here that we defined called issues_master. And this table has basic information about issues. It has all of the main elements for issues, and then it also has the assignee and the label, which, if we remember, there are different tables that exist for that, and we are putting that into one single table here. So, right, we save this, and now how will it come into existence? That is basically, we will write a SQL file for it. I'll call it master.sql. And we will join all of the tables. And it's a long query that I will not write again. So here it is. Right, so what did we do? We took data from our main issues tables. We took the ID, URL, some basic information about who created the issue, when it was created, when it was updated. And then we will join the issues assignees table, and we will get whoever this issue was assigned to from the dlltHub team, and then what label it was assigned from the issues_labels table as well. So now that we have all of that, we've created the models, and in a normal DBT project, you would have other, testing and running commands that you would execute here. But with DLT, you can simply run the DBT runner, which is basically, so this is an optional step here, attaching a virtual environment to your DBT runner. But basically, we have the same pipeline that we created in our first initialization of this data set, which is GitHub issues merge. So it will be referring to the same pipeline, the same data, not the same data set, the same pipeline. And then we will have another data set called modeled issues. If you remember, we did not have this before. We just had one data set called GitHub data merge. So we will create this particular data set for our modeled issues. And then we will basically declare our DBT runner, where we will give it the proper name, runner_workshop, which is exactly the DBT project that we created. And it will basically do a DBT run all. If you're familiar with DBT, that is how you run all of your different models, but you use different commands for that. Here you can just do that all within Python. So for this, yeah, let's just execute this. Everything else is there. Python modeling.py. There's a lot of awkward silence in this workshop. But anyway, so we materialized the model called master, and we will actually not look into the DuckDB database this time. We will look into the DBT docs. And how we do that is basically we'll go into our DBT directory, our project that we just created. We will generate docs. Now we'll use the DBT commands for that. DBT docs generate. Cool, it's written into this target folder. And now we will look at it. So this is actually, I particularly love this feature. DBT docs, now we just generated it, we want to serve it. And you can do it within your own local host, and I will give it, by default, it takes the 8,000, I think, but I don't know how many things I have hosted right now, so I will tell it to host it on port 8009. Cool, so this is the runner workshop that we just created, and if we look into models, we will see what we just created, and it's right here. And this is materialized as a view because we didn't say anything else. If we wanted to materialize it as a table, we could have done that, but we didn't. It's just a view. And yeah, so that's basically your DBT project that you ran entirely inside DLT. And you were able to finish your entire extract, load, and transform with the DBT runner here. So that is it for my part. Wow, I have so much open. I'm just going to stop sharing my screen, and Alena is going to come back.
So guys, I'm ready for my part because my part is also interesting as Hiba's. So it's not done. Do not leave. So later, now we will discuss performance optimization, custom sources, custom destinations, and deployment. Let's start. So go to performance optimization, collab section. Now we're going to discuss how DLT works under the hood and how can you play with settings, how you can improve performance or probably make it even worse. So let's see. I will run this cells in advance and let's go to, I already have it. Okay, let's start with understanding. What is pipeline run? What's happening under the hood? A basic DLT pipeline has three main steps. It's extract, normalize, and load. All these steps running silently. Usually you don't know about them, but you should know how each step works. So extract step fetches the data from source system and write to local disk. So all your extracted data will be written to local disk in files. Then DLT reads extracted data from local disk, infers schema on this step, transform your data, and write transform data to local disk as well in the separate folder normalized data. And as a third step, load, this step reads normalized data from local disk and ingests it into destination system. So on this step, so ingestion happens. Let's start with extract step. let's talk about it in more detail. When pipeline run method is executed, it first performs the extract stage. During the following occurs. First, data is fetched and stored in memory buffer by one or multiple thread workers or async generators. I prepared this small illustration to show you briefly that when you yield your data from API or database or any place, when you yield your data as a Python dict, DLT extract this data to intermediary files. So first it saves data in buffer, in memory, and when it's reach the limits of this buffer is cleared, and DLT writes data into files. And next. When we use several threads, DLT can run each resource in parallel. So you can see here. So first your resources went to thread pool, and each resources can be run at the same time. And all your data will be stored as intermediary files in your local storage. So let's talk about default behavior. So by default, in-memory buffer is set to 5,000 items. So it means DLT first store your data 5,000 items in memory. When it's 5,001, DLT will write your data in files and clean the buffer. So default number of thread workers is 5. The default number of async functions in parallel is 20. By default, intermediary files are not rotated. That's very, very important. If you do not explicitly set a size for an intermediary file with the file max items, and there's any number here, DLT will create a single file for a resource, regardless of the number of records it contains, even if it reaches millions. So if you work with big data, you should always enable this parameter, because by default, DLT will use only one intermediary file and load all your data, extract all your data in one file, then normalize it in one file, and then load it as a big one pack into your database. If you have million rows, you probably will have some problems with loading. And by default, intermediary files at the extract stage use a custom version of the JSON-L format. JSON-L, it's just a list of JSONs. So how we can optimize extraction? By default, DLT is quite optimized already. So if you run vanilla pipeline, it will have good performance speed, but you can, for a different situation, you can try different set of parameters. For example, you can control in-memory buffer size for the extract stage. If you have a lot of data, it could be bigger. Or if you have not enough memory, it could be smaller. Also, always group DLT resources into DLT sources, because under the hood, DLT will create separate source for each resource if you run them sequentially. We will discuss it later. Also, we can specify the number of thread workers or workers for async generators. Also, always yield pages instead of rows. If you yield row by row, it will call function too many times. You don't need it. Also, we can customize the size of intermediary files. If we take too small size, we will have a lot of files. So it can also affect our storage. If we take too big, we will have too big files, big packs to ingest your data into database destination. Okay, let's look at the example. We will start with the worst case scenario. We set buffer max items to 1. It means that DLT will process your data row by row, one by one, and write your data into intermediary files one by one as well. So your buffer will be 1 instead of 5,000. Also, we set explicitly extract workers to 1. It means also that all your resources will be processed one by one. First, you will get your data from database cursor 1, then from database cursor 2, and so on. Run this pipeline and can see that it takes 43 seconds. It's only for extract step. Let's try to improve this. First, we will increase the buffer size to 50,000, because here we have 50,000 rows for each resource. And run the pipeline and can see that it was improved, significantly, I would say. And let's try to combine all your resources in one source. As you remember, if you run your pipeline with the resources as a sequential, as a list, DLT will create DLT source on top each resource separately. That was not very effective. So we should combine them first in DLT resource, group it, and run one source here. But as we can see, there's no improvement in speed, but sometimes it is. So let's try to increase the number of workers. Previously we had 1, now we set it to 3, because we have 3 resources. So let's try to make it parallelized. So each worker will process 1 resource. And yes, we can see there's small improvement, so that's not bad. It works. Let's go further and try to do a very important thing. Let's try to yield pages, slices instead of rows. In this code, slice your rows to chunks by 1,000 and yield them 1,000 rows in chunk. And run the pipeline and can see, oh my God, it took just less than a second. So if we compare this previous one, it's almost 30. If we yield it as pages, it takes just less than 1 second. That's incredible. Go further, and what happens at the normalization stage? At the normalized stage, DLT first transforms the structure of the input data. This transformed data is then converted into a relational structure that can be easily loaded into the destination. So on this stage, DLT will infer your schema, set the data typing, unnest your data, do all this DLT magic on this stage. Usually this stage is more, it takes more computational costs, and you can also improve the performance on this stage. Let's look at this illustration. As we already know, when we get our data on this extract step, DLT will write it to intermediary files and save it in your local storage. Then on the normalized stage, it already goes to process pool. So because we work with the files, it's impossible to use multi-threading. We use multi-processing here. So each process will processing one file. As you remember, if you set max file items, DLT will create several files. If you skip it, DLT will create one big file. And in this case, multiprocessing doesn't help you. So one process, one file, and also it based on buffer. DLT process your data and also store your data on in the local storage as files, but already in a normalized form. Okay, let's talk about default behavior. In memory buffer is set to 5000 as in the previous stage. As mentioned above, the default is not to not parallelize normalization and to perform it in the main process. By default, intermediary files are not rotated as well. Yeah. So I skip this information. If parallelization is enabled, these files are concurrently handled by multiple workers in the process pool. If parallelization is not enabled, which is the case by default, normalization is performed in the main process. Yeah, that's important. How we can optimize normalization? To optimize it, we can specify number of process workers. Be careful, yeah, because it's you should know how many processes you can run, or you can make it worse. Also, you can control memory buffer size and customize the size of intermediary files as on extraction step. Let's look at the example. We disable compression to slow it down and set normalized workers to 1. Actually, by default is 1 as well, and run it. We can see we run just one step, normalize. On the previous example, we run just one step, extract. So we can see that normalization step takes 42 seconds. If we increase the number of process workers, here we run it again because we need clean extract step. So we can see here we extract data again. And let's normalize it with normalized processes to 3. And can see it was significant improvement, 7 seconds. Comparison with one process, 42. The last step, the load stage is responsible for taking the normalized data and loading it into your chosen destination. Using a thread pool, again, not processing, a thread pool for parallelization. Here's a detailed explanation of what happens during this stage. So first, DLT, as you remember, DLT extracts your data, save it as files, then normalizes processing your data, transform it in first schema, and save normalized data as files again. And during the load stage, DLT using multi-threading or one worker, it depends on your settings, to process your normalized data and load it, ingest it to your destination database, usually. So as we can see, one normalized file per worker. Loading happens in 20 threads by default, each loading a single file. So again, if you do not set max file items parameter, DLT will store your data in one big, huge single file. And also, DLT will try to load your data as one big package of data to your destination. So how we can optimize loading? There's not many options. We can also only control the number of parallel threads. So by default, it's 20. You can play with it. Sometimes if you take less, it works better. So let's compare. If we take just one worker for loading, and will load your data file by file, one by one. So it takes 67 seconds. If we load our data again, but we increase the number of workers to 3, we can see how improved the performance, how it increased the speed. Also, let me briefly tell you about async option. Also, you can use, instead of parallelized parameter, you can use async. So the example below does the same, but using an async generator, the main resource, and async await and futures call for the transformer. So let's go to follow us collab right now and try to play with the parameters. First, the main thing what we should do, we should set parallelized true. You should, you probably missed it in the collab because I didn't mention it, but to enable parallelization, you should set it for each resource. That's what we're going to do right now. I will give you 1 minute to fill this resource parameters and set parallelization true. So, Hiba, now your turn to make a joke. Yeah.
I said that I will be sharing memes later.
Okay.
What I think Motion is sharing jokes.
Can you show me the comments if there's something? Just curious.
This was a question.
Huh?
This was a question from Ludovico.
We can answer. There is a question from Ludovico. Okay. We have 10 seconds. I guess you did it because it's not really difficult.
Which question?
That's it.
And let me show you. Yeah. So that should be true. I'm just gonna copy it. And run the pipeline. A grant access, yeah, because I use GitHub token here. If you do not use it, you can remove access token from this example, but there is a chance you will face the rate limit. So it takes a while because we in this example we use very heavy endpoints. Yeah, I forgot to rename it, but yeah, in here we use branches, commits, and stargazers, and that's wait. So, as you know, if you print pipeline last trace, you will see each step timing. Yeah, step extract completed in 27 seconds. Step normalize completed in 2 seconds. Very easy. And step load completed in 9 seconds. Good. Also, we can see how many rows we have for each endpoint. Branches, we have only those 106 rows. Commits, we have 3,000 commits and more than 2,000 stargazers. Okay, let's play with the parameters. And first, let's set explicitly the number of thread workers for load stage to 5. I'll give you a minute. You should remember that how we convert our config toml configuration into environment variables. And remember that numbers should be strings.
You should give prizes for the best joke.
I think I win. I love my jokes. 7, 6, 5, 4, 3, 2, 1. Woohoo. Let me show you how to do it. First, we write load, then double underscore, and workers, and equal 5. Numbers should be strings for environment variables. Let's run it and see. See if there any difference. Yeah, sometimes when you're playing with parameters, you can see the improvement, or it's even getting worse. So okay, step load completed in 11 seconds. Yeah, when I prepared this example, it was vice versa. But well, that's not a point. Yeah, we're not trying to improve anything here. We're just trying to play with parameters and see that you have this control. Okay, next task will be, it's very important again. We will try to enable file rotation. Let's set file max items to any number you want. Yeah, here's 100,000, but I suggest set it to just 1,000 because we have the maximum number of rows. We have 3,000. Yeah, and as you already know, by default, intermediary files are not rotated. If you do not explicitly set a size for an intermediary file with a file max items parameter, DLT will create a single file for a resource, regardless of the number of records it contains, even if it reaches millions. Again, very important. So I'll give you a minute to set this parameter. Oi.
We should advertise this as why you should join live workshops.
Yeah, because recently we received so many questions about why my million rows cannot be loaded by default. Yeah, it's actually not obvious. You should know what to change.
Yeah, I mean, I didn't know this before.
I didn't know before before this workshop.
Yeah, I learned a lot from this
Yeah.
workshop.
Okay, 10 seconds. I hope you finished it already. Okay, let's set it. First, data writer, then double underscore, file, max items, equal 1,000. Run the pipeline. Surprisingly, it helped to improve the performance. Previously, we had 35 seconds. Now we have just 29. That's good, good. Yeah. Load step completed in 5 seconds instead of how much we had, yeah, instead of 11. That's cool. That's nice. Okay, go further. In this section, custom source REST API helpers, I will show you how to use DLT REST API helpers. So as you know probably already, DLT prepared really cool helpers like REST API source, REST API client, and now you can build your custom sources quickly and without much coding. Yeah, you still have to know Python, but okay. So this demo starting with before we start implementing source, we should investigate the API. Before we start implementing source, we always read API documentation. Here we can find
There's a question saying, could you talk a bit more about the use cases for increasing number of workers?
For example, if you have different settings on your machine, you have just one worker, or you have 1,000, I don't know, you can change it. So you can control it. Of course, 3 workers will perform much better than just 1. So it should be clear. Is it fine answer? So, okay. Before you start building a custom source, you should read documentation. You should know base URL. You should know authentication type. You should play with response. Yeah, you should curl with the curl or CURL. I don't know how to pronounce it correctly. Or with Python, you should investigate what pagination type it has. Does it have rate limits? Yeah. What query parameters it has. So just imagine that we already went through the GitHub documentation. We know the base URL, we know the authentication type, we know the pagination type, we know how to handle rate limits, and so on. And let's start with building our custom source, GitHub API source, but using DLT helpers. We start with low-level helper. We call it REST API client. It includes features like automatic pagination, various authentication mechanism, also customizable request response handling. Usually, if you know what type of pagination API has, it's not enough to build your custom source. Also, you need to handle this pagination, or you need to build some function to handle authentication. Also, you need to process your data, yeah, somehow. DLT trying to do it for you. To use it, you need to just install DLT and import DLT requests. So it's almost twin of original requests, but DLT provides extra features like retries and something else. Okay, let's start with our typical example when we're trying to retrieve data using requests library. So the pagination looks like while true loop. So we request API until we see that there is no data in the next request, and we break the loop. So it's a very classic approach to handle pagination. It will be useful for your first homework. So yeah, we define DLT resources as usual and yield pagination. Let's rewrite this basic low-level example with the DLT helpers. So For this purpose, we need to import REST client. From DLT sources, helpers, REST client. Yeah, import REST client. Also, we know that the GitHub API uses bearer token authentication. Also, let's import it and set explicitly. Let's define the client. So it's quite simple. You create the REST client object, set base URL, set authentication type. DLT REST client also can automatically guess what type of authentication your API has. In this case, you don't need to provide any authentication. It will be chosen by default somehow. Also, same situation with pagination, but sometimes, as you know, APIs are very different. Sometimes they makes no sense, and you have to provide authentication and pagination explicitly. So in this case, we set bearer token authentication, set token using environment variable, and request the API. Get method takes the list of parameters. The required parameter is endpoint name. In this case, we use base URL and endpoint. Let's see the data. So yeah, there is our issues. Let's add pagination. As I said, sometimes DLT guess what type of pagination you have and does it perfectly. For example, for GitHub API, it guessed what kind of pagination it has. And you can use paginate method of client and retrieve the data. So if a pagination type wasn't detected automatically, you can provide it explicitly. In our case, the GitHub API uses header link paginator. Okay, let's declare a source using our client helper. We declare a source as usual with DLT resource decorator, set function, and iterate over pages using client object and paginate method. Also, paginate method takes not only required endpoint name, but also parameters. Yeah, you can see more okay, I can't say more. Okay. You can set incremental loading as usual for DLT resources because this client uses very basic DLT resources. So we skip it because we talked about it already. You can easily add more resources as a simple DLT resources, and each resource will use their pagination and retrieve pages. Yeah. Good. Also skip it. It's transformers. We already discussed them last week. So now it's really sweet things. It's a REST API source. A few months ago, DLT team prepared a REST API source, and which you can use to quickly build DLT resources using declarative interface. Let's look at this. First, okay, it's not few weeks ago, DLT released REST API as a part of DLT core, so you don't need to initialize REST API source anymore as a verified source. You don't need it. You can import it directly from DLT sources. Yeah. REST API. And you can set up config as follows as a Python dict. First, we define client, provide here base URL, pagination type, authentication type, any other parameters, and then we describe our resources we have. In this example, we declare resource issues. So here we give resource name first and set endpoint path issues. So run this config. In the REST API source function creates DLT resources from this config. And so in the end, you get GitHub source you can run as usual using DLT pipeline GitHub source. Yeah, all your data will be loaded. How to add authentication? DLT REST API config also will try to guess. Okay, REST API source has DLT REST API client under the hood. So it has the same features as REST API client, but with a more declarative interface. So here we set authentication, we provide token. Also, we can provide authentication explicitly using authentication using REST client authentication. So we can just set here instead of this. Same thing for pagination. Also, you can provide params, query params in here. So each endpoint has its own set of parameters, like endpoint parameters. Endpoint also can set different type of pagination for each endpoint. You can set some actions. Let's go further. I will show you. Add more endpoints. Oh, okay, there's very important part I skipped. How to set incremental loading for REST API source. Well, each resource will have has its own set of parameters like name, primary key, right disposition, and endpoint description. So your params can include, for example, for GitHub API, you can use scenes to make your request incremental. So if you set type for this parameter as incremental, next time for next run, DLT will request only newest data based on last value of the updated add field. Okay. So let's add more endpoints here. So it's very easy. We have some defaults here. We can set them for all endpoints. For example, primary key for all endpoints will be ID. Right disposition for all endpoints will be merge. Some defaults for endpoints, for example, per page 100. Yeah. And after that, we describe each endpoint separately. Issues will have this set of parameters. And if we set pull request here, it will have its own set of parameters. In our case, they are the same. Also, you can set child endpoint transformers, as you remember from the previous week. In this example, we'll try to fetch comments for each issue. First, we declare resource issues. We get all issues from this endpoint. After that, we will take issues from the resource issues, and item by item, we will request issue comments endpoint. I know. So there's a path. Okay, what? So I'm lost. I don't. So it should be like comments. Should be issue number, and here should be comments. And issue number will be resolved from issues resource. So that's correct. That's the old one. That's the old, not. Okay, continue. I added a few sections. They are advanced. They are very important when you're trying to build resource using REST API source. For example, sometimes you need to catch some errors or do extra steps for your response. You can use response actions. It's just a part of endpoint description. When you set path for endpoint, you can set also response actions. It looks like a list of actions. You can have several of them. For example, if your response return 200 status code, it means that it was successfully requested. You can do some action for each response. And the content, it's a substring to search for in the response content. For example, your do something function can look like, you can print your JSON, a response JSON for debugging, for example. Okay, next very important part, it's a very new feature. You can add processing steps, so you can transform your data. You can use filter and map function. If you work with the DLT resources, low-level resources, like DLT resource decorators, you should know that DLT has apply map function, and you can use it to transform your data before loading into your destination. You also can use it for REST API source for this declarative interface using processing steps. So it can include several actions. Also, you can have several filters or maps. For example, your map function will have lower title, the next form. So the record, it's one item from your data. You can do anything you want from this with this data. For example, make all titles lowercase. You can filter your data. For example, you want to have IDs less than 10. It also takes Lambda functions or regular Python function. So that's it about REST API source. And let's go to the tasks. I think you are getting tired already. So it's also the very easy task. Let's add extra endpoint for this pipeline. So in this example, we have issues. Let's replace it with polls. I will give you 10 seconds for it because it really, really should be easy. 10, 9, 8, oh my God, 7, 6, 5. Yeah, I am gonna change it here. Name, again, I remember you that the name, it's a name for resource. So we can have any name you want, like pools resource, for example, super. Yeah, so any name. But endpoint path, it's your endpoint path. It should be exactly like in API documentation. Let's run this. Yeah, here we can see we use REST API source function, provide GitHub config here. DLT will create automatically all resources and run the pipeline as usual. Yep, data is loaded. Wait. It's a table name. It's not resource name. Interesting. I thought it's because yeah, it's a resource name. But if you provide here table name, it will be okay. Yeah. Now we have correct table name, and data was loaded. Okay, let's go further. We have very interesting topic, custom destination. I forgot to attach the link. Let me share it with you. Should be shared. Okay. As you know, DLT provided functionality for data loading. So you load your data from source to destination. Sometimes you have you need to have some custom destination because DLT has limited number of destinations, but sometimes you want to create your own. It would be useful for reverse ETL, for example, if you want to send back data to API, or for custom destinations, like sending data to a queue or a database that DLT doesn't natively support. Also, for direct file access, it's allowing you to work with path to your normalized data files, such as Parquet or JSON. Okay. For this collab, we will take a top-down approach, starting with an example and then exploring all the intricate functionalities. We will discuss Notion example as a custom destination. So Notion is a DLT verified source, as you could know, but there is no DLT integration for it as a destination. You might be wondering why bother defining it as a DLT destination if we can just use the Notion client or another connection option. Yeah, good question. But DLT provides all functionalities using DLT destination decorator. And if you want to use DLT for loading data, so it's also a very convenient way to just wrap your client. That's it. So I'm not going to run this code. It's just example. You can play with it later after the workshop. So first, we create Notion database. It's like preparation. Or we can use UI and create this database. Then we create our GitHub example, GitHub pipeline with extra resource as a transformer. It doesn't matter. We do not talk about DLT resources right now. We will try to build custom DLT destination using DLT destination decorator. So first, we define client, Notion client. It's we install it first. So it's a package. So define the Notion client, authenticate it using DLT secrets as usual. Yeah. So DLT destination decorator gives you opportunity to use all DLT destination features like credentials, unnesting, schema inference, and so on. Then we take our items and load them into database directly. So that's it pretty much. And let's run this pipeline and run it pipeline as usual, but instead of DuckDB or any other destination, existing destination, we use our custom destination Notion create function, this function. So create pipeline, set custom destination as destination, and run the pipeline. Extract properties, it's our DLT transformer from to just DLT resource. So yeah, our data was loaded into the Notion as expected. That's good. Let's discuss a little bit DLT destination decorator. What exactly happens in this function? When running in a pipeline, this decorator enables your custom destination function to receive all data items processed by the pipeline. So it will retrieve the data from DLT resource into this function. That's first. Then, in your function, the items parameter contains all data items, while the table parameter holds the schema table corresponding to a current call. Also, I want to notice that table is just a Python dictionary, type dictionary, and you can use it. Yeah, you can get all columns. You can check what right dispositions it has. Yeah, you can see that columns data typing and so on. Also, this decorator DLT destination accepts several parameters like batch size, loader file format, the name of your destination, also what naming convention you want to provide, if it's a direct or if it's a default DLT naming convention. Also, you can set max table nesting, so how deep your data should be unnested, and parallelize. So more detail about these parameters you can read later. We will we'll go back to our follow us collab, and let's try to build custom destination. So as you can see in this example, I try to build pandas destination. So you can't see it. There's no text. But this task will be about, oh my God, where is the task? It wasn't saved. Task, I don't know, 10. Yeah, build pandas destination. And here we will try to load our issues from GitHub source from this example. From this GitHub source, we will try to load. Here we have no issues anymore. We have pools. Let's replace it. Pools. We will try load this data into pandas data frame. And as you know, GitHub API response has nested structure. It's just a pure JSON. And you can ask me, Alena, how you want to put this JSON into pandas data frame? Because the pandas data frame has relational format. And I say, yes, that's true. For this purpose, we will set max table unnesting to 2, for example. I'll give you 1 minute to build my destination, custom destination to pandas. You should use items and load them into pandas data frame and save it as a CSV file. Let's do that. Do they have questions about it? Nope. Oh, okay. Oh, no. Wait. Yeah. Okay. Actually, we're running out time. Running out of time. And yeah, the workshop will take a little bit longer because we have one more section. It's deployment. We have 3 examples. Okay, we'll see. Maybe we discuss just 2 or 3. Or 2 or 1. Okay, time is almost over, 5 seconds. And let me show you how to complete this task. First, we need to create pandas data frame. Data frame, put our items in here, and save it as a CSV file. Let's run this pipeline and see. Okay, rename table name to pools because we're loading pools, not issues. Hey. Okay, yeah, our resource name now has different name. Pools resource super mega. Okay, let's run it. Okay, as you can see, that table has dict structure and next keys like name, columns, parent, what type of normalizer it has, and right disposition. Also, your data was loaded, and we can see how many tables were created. So the DLT unnested your polls responses, and let's look at them on this data frame. Here, we can see that user key was unnested, and also yeah, head key was unnested. So in original, it was just one big JSON. You still can have it if you set max table nesting to 0. Okay, we have last section, deployment time. Woohoo. You can follow me or you can just watch, but for this purpose you need to clone the dlltHub application repository. Okay, let's start this GitHub action. To deploy a pipeline with GitHub Actions, first you need to install DLT, you need to create a pipeline, and sign up for GitHub account, since you will be deploying using GitHub Actions. So, if you clone the dlltHub application repository, you can see in Workshops folder, Workshops September folder, Part 2, Deployment GitHub Actions, you can find GitHub pipeline.py. It's our very familiar example. We get issues and pull requests. Okay, So it's a very typical DLT source. Nothing else. What is next? Before you can deploy, you need a working pipeline. So DLT should gather all metadata from your pipeline. So let's first run it. It's necessary step. I'm already in the GitHub Actions folder, so I can just run this command and see. One issue was created since I played with this example. Okay, let's remove my old database and run it again. Okay, all issues were loaded into my DuckDB database. Okay, what is next? Next, we should install our DLT deployment helpers with DLT install DLT CLI and run the function DLT deploy. In our case, we should use our GitHub pipeline Python script and then comment GitHub action because we need we want to deploy our pipeline with GitHub Actions. Also, we can set schedule right here. So like this, it's a very basic cron job, cron schedule. I don't know how to say it. So it means that GitHub workflow will run your pipeline script every 30 minutes. Let's run it. Here you can see the small instruction. DLT looked up the deployment template, downloaded, filled, used your pipeline metadata to create workflow files, such as run GitHub issues merge workflow YAML in the GitHub workflows folder. You can see it here. GitHub workflows run GitHub issues merge. It's the name of our pipeline. So we'll be careful with the name of your pipelines. The schedule is every 30 minutes. The dependencies are stored in requirements GitHub Actions txt. Yeah, there's including DLT package. We should provide them explicitly DLT and DuckDB we use it. So what is next? Our pipeline doesn't need any secrets, so we don't need to use environment variables for them. But if you have, usually you have secrets, you need to provide them into Git UI. So let me show you here the secrets. Yeah. So you can find in the settings, in secrets, in actions, you can find the environment variables you can fit. And if you have any secrets in your config secrets toml, DLT will print it here in correct format. So you don't need to rewrite it uppercase with double underscore and so on, just copy it and paste. So next, we need to add stage deployment files to commit. I'm going to do it using PyCharm because it's easier. So first file, workflow, then requirements, GitHub Actions. Yeah, it's already in here. And commit files. Yeah. Commit and push. So your pipeline should be running. You can monitor it here. Yeah, very convenient that you already have link to your actions. So it takes a while to create an action. So let's wait. Yeah. So the action is already created. Yeah, we can see GitHub issues merge pipeline from GitHub pipeline.py. We can trigger it manually, like run workflow. You can find all actions in your GitHub repository. In my case, it's GitHub Education and Actions section. So you can see that it's in progress. Okay, go further. Let's discuss the next tool. It's Dagster. Many of you already know Dagster. Dagster is an orchestrator designed for developing and maintaining data assets, such as tables, datasets, machine learning models, DLT pipelines, of course. And to learn more about Dagster, there is a link to documentation. This README you can find in our DLT education repository in workshop September, part 2, deployment, deploy Dagster. So let's start with installation. We use pip install Dagster, and also to use built-in DLT Dagster integration, we should install Dagster embedded ELT package. Let's run it. Okay, it was installed. And set up Dagster directory structure. Let's create some directory temporary folder. For this purpose, and initiate the project, Dagster project with common Dagster project and the name. So let's look at this. Yeah, it was created, GitHub source folder. Here you can find assets script, definition script. Here we will provide assets and definitions. And the only thing we should do, we should add DLT pipeline. So in the repository, I prepared DLT pipeline, GitHub pipeline. So it's our same example. In this case, it's only issues, but we can add more. So let's just copy this pipeline and move it into our GitHub source folder. Okay. So now we have all scripts together. Well, what is next? Create DLT assets definition. In this workshop, we will use DLT assets. It's a built-in integration. You can also use basic Dagster assets, but if you have very simple DLT pipelines, I recommend to use DLT assets. It's very convenient. So, first we need to import it from Dagster embedded ELT package as DLT assets and use it as a decorator, which takes few parameters. First is DLT source, and second is DLT pipeline. So let's use our GitHub source from the GitHub pipeline.py script and move it to assets here. Also, DLT assets takes only DLT source. You can provide resources here. It should be always grouped in source. In DLT pipeline, you should describe your pipeline name, dataset name, destination, and any other optional parameters like progress log. Okay, and here in the function we should yield from DLT run. Okay, we set assets, Dagster assets. Let's set the definitions. We should set them in the definitions.py script. What it includes? It should include Dagster DLT resource. So it's custom Dagster resource, special for DLT. Let's set DLT resource. Let's collect all assets we have in our assets script and set definitions. So let's run web server locally and see if it works. It doesn't. Okay. We should go to GitHub source folder and then install this the Python package using as an edit mode. So yeah, you can see there's a poetry toml file. Yeah, it was installed. Good. Let's run Dagster dev. Yep, it works. Let's try to run the pipeline. For this purpose, we should go to runs prompt. Go to assets, pick the get issues set. Okay, it's default. And run the pipeline. Yeah. To run it, I pressed materialize selected. Materializing is in progress. We can look into our logs for now. So run success. Yeah. It's already a very well known logs, DLT pipelines. So it was run successfully and all data was loaded. Good. That's it about Dagster. Oh, we had a little bit of time. Let's discuss Lambda function. We can find everything about Lambda function in the dlltHub education repository workshops part 2 deployment Lambda function. There is a README. Yeah, to run Lambda functions, you need to first, of course, AWS account. I have it, so I'm going to show you how to use it. First, we need to prepare DLT pipeline. We're going to reuse our DLT GitHub pipeline again, but the only difference is that we wrap it into the function with the name Lambda handler. So I modified it a little bit. At the end, I return status success. Yeah. Also, there's a small check if it was loaded successfully. Okay, the pipeline is ready. Log into the AWS Management Console. Let's do that. Already here. go to Lambda. Here you can see all my Lambda functions here. Create function. Let's create it from scratch. First, we need to set the name for the function, workshop, September. Pipeline, runtime. I'm going to pick Python. Python 12. RM64 architecture and create function. You can find all these steps in the README. Create function, choose authoring method, configure basic settings, and create function. What is next? Here we can see the editor. We can just copy paste our DLT pipeline in this editor. Let's do that. So it's our regular DLT pipeline. The only difference is that we wrap it into the function, which takes event and context parameters, and return status success. Before we run it, we should deploy it. We should save changes. And I don't know, let's test. Yeah. Create test. Some workshop test. Save and run. Okay, error message. No model named DLT. Yeah. Lambda function, run it in the pure environment. So first you need to install the DLT package, and also we use DagDB as a destination. It means we need to install DagDB as well. But there is a small problem with it. I described it here. I'm going to skip the whole process of creating an environment with Docker because I have MacBook with different with ARM64 architecture, but AWS Lambda doesn't support it. It supports only Linux. So I prepared the like fake environment using Docker. So I loaded Linux image. I installed a DLT and DagDB inside of this Docker. So I run it interactively. And created a package. So I just copy pasted the opt Python all installed packages into test folder and zip it. So we run out of time, so I skip this step and gonna use prepared layer here, add layer. So you should have same runtime as you set in the function settings. So it's you can see here I used Python 3.12 and Linux ARM64 architecture. And let's choose. I have where is mine? Custom layers, yeah. Custom layers, dlltHub ARM64 Linux version add. Okay, we installed DLT and DagDB, and now we try to run our pipeline again. Let's test it. Okay, it's failed with timeout after 3 seconds. So I think it's 3 seconds not enough to load any data. Let's go to configuration. In general configuration, we can see that our timeout is 3 seconds. Also, we have just 128 megabyte of memory. Let's change it. First, we need to increase it. Yeah, for example, 100 and timeout to 3 minutes. And save. Let's go to code, test. It's failed again. We can see that read-only file system. That's true because now DLT is trying to create these intermediary files into a read-only directory. We need to switch to data dir to another one. Let me show you how to do that. Go to configuration, environment variables, edit, add environment variable, and change our data dir, which is home by default, home.dlt, pipelines, yeah, by default, as we know. But Lambda function, they have some writable directories, so we can use them. For example, temporary directory. And as we are here, we also should set the path for DuckDB database down, because it will try to be created in the home. It's a read-only folder as well, so we need to change it to temporary folder. Let's save it and run again. Let's test it. Let's check our temporary. So what's what I forgot? What I forgot? Nothing.
Someone's saying the environment variable is DLT data dir instead data dir.
DLT, right? Yeah. Yeah, you're right. Edit. Save. Code. Test. Okay, it's not failing. Very nice. Hey, status success. Okay, you can find the whole tutorial in the Lambda function folder in our dlltHub education repository, and repeat it if you want at home. So that's it for now. How to stop presenting? Where is the button? No. So me and Hiba, we want to say thank you guys for participating, for sitting here, 13 people and listening us. We will send you feedback form. Please fill it, because your opinion is really important for us. And do homework, because it's interesting, in my opinion, also. Thank you.
Thank you.
I don't want to leave. I like. I really.
You like seeing yourself?
Yeah, it's good. Thanks, Farrell.
This is so amazing that these people are still there.
Yeah, sure it is. Oh, okay, 12. Okay, we will share all materials, all links, recordings, everything tomorrow or next week. So now we have enough time to also we start checking your homework. For example, Nikesh will start doing it soon, and see you in a few months or next month for another workshop. Yeah, I think it's time to go.